Hello, my name is Paul Higgs and I work for Huawei Technologies. In addition, I'm also the chair of the DVB Project's working group TMI, where we're developing technologies for delivering linear television over the internet. I'm going to talk to you today about the DVB-I project and what we've been working on. DVB for a long time now has been developing specifications which support television, predominantly in the broadcast space, and you will know us for our work on satellite, terrestrial and cable delivery systems for television services. These are obviously recently been supported by lots of additional enabling technologies which bring interactivity and other features to the television experience. From an industry perspective, we've also seen that the internet has really grown in the last few years and has matured to a level where we make it possible to deliver linear television and all video content to a very, very wide audience. Of course, live linear television has certain characteristics, but those technologies that have been developed by the internet community are certainly capable of supporting now very wide scale delivery of television. We've seen this a lot recently with some of the broadcasts of sporting events on using internet delivery techniques, and also the recent SpaceX launches. So DVB then a few years ago looked at what needed to be done and tried to determine what we need to do in order to make sure that we can use internet technologies to reach new customers who are now using new devices that we haven't necessarily used before, and make sure that we can offer them the new types of services that are probably needed and related to the traditional broadcast, without letting go of a lot of those activities and those experiences which people have come to expect from a television service. So there's four major parts to the DVB-I specifications, and I'm going to talk about a few of them in different levels. While I talk about DVB-I as a project, it encompasses lots of different areas, and one of those areas is the service discovery and content metadata specification, and I'll talk about some parts of that right now. This specification gives four main characteristics. The first is to be able to find television services. We know that we use internet services like Google and others to find web pages on the internet. And this is a part of the experience which is really baked into the computers that we use day in and day out. We don't always know that we're using a search engine. We can just find things on the internet, but we don't have that necessarily available for television services. Not in the same way that we have a television scan service now. We plug in our new television, we connect it up to an antenna, we get it to scan and find the channels which are available on the delivery system, and then start presenting them. There's no easy way to do that with an internet service, so we have to find some way to make curated lists of services available to consumers on IP devices. When I refer to IP devices, I'm not just talking about television sets. I'm also talking about mobile devices and tablets, computers, and other equipment that we'll start to use more and more often to consume television services. Services then, as we define them in the A177 Blue Book, which is the service discovery and content metadata specification, are defined as an editorial instance of a service which can be delivered by a broadband or broadcast, or both. Then we define a concept called a service list. Service list is a way that we can curate a series of associated services into one specific offering towards the consumer. So service list may be regional, it may be defined by a regulator in a market or a territory, it may be defined by an individual or another organization purely out of self-interest and bringing together services which they think are useful to a certain audience, and more of a demographically oriented service list. That's great. Now we've got these lists of services, lists of television channels, we can call them whatever we like really, but we've got all of these, and now we need to find them. The device itself, the mobile phone or the television set which is connected to the internet, needs to find these lists of services available. So we have a concept called a service list registry, and this is where we do our discovery function. The device has a standardized way to interrogate a service discovery server, and obtain a set of services or service lists that it can use. We can query this. We can ask for service lists based on characteristics such as target country, whether it's a regulated list provided by a regulated authority in a country, or it could be services based on a genre. We expect to see service list registries coming online over the next few years, and sooner in order to start this activity off. So the second part then of linear television over the internet is delivering the content itself, and we refer to this as streaming the content because that's really what we're doing. We're using internet technologies to deliver these services using segmented media, and for that DVB has a specification called Blue Book A168, which defines a profile of MPEG- for delivering linear channel type services. This is a profile which has been tailored towards some of the needs and expectation of broadcast services, and it includes aspects such as organizing the timing and the timing expectations of the client device. We can also do some things in here to signal events outside of the media stream for advertising and other interactive services. One of the things we do with DVB-I then is enable the possibility of signal services in a simulcast manner. So a single editorial service can be delivered with broadcast and broadband content, as I mentioned before. This allows interesting scenarios which could be a fallback from a high quality broadband service to a standard definition or high definition broadcast service, or it could be a high definition broadcast service with a fallback to a high definition broadband service. One other example is a high definition or standard definition broadcast service, which could then fall across to a high definition broadband service at certain periods of time. We can schedule the broadband aspects for intervals, and we can align some of that scheduling then with regional information. So we can do a regional insert, a program insert at a regional level on a time basis within a broadcast delivered service. This really helps us to provide an interesting experience for consumers and make sure that they have the ability to see the content regardless of the delivery mechanism. We're not aiming yet for a seamless transition between one delivery system and another. We hope we'll get there in the future. At the moment, we're looking at making sure the user experience is not disrupted when a switch happens. There may be a slight delay in the transition time, and there may be a few frames dropped or a few seconds of dark screen, but the general intent of the programming will be allowed to continue. If the switch is from broadcast to broadband, the network can provide backup and replay services, so the user could then time shift backwards in the content and catch up on anything they might have missed during the transition. The third aspect then is presenting the content and presenting the information that goes with it. We can stream a video session to everybody, and that's generally something that's quite straightforward these days. We've got many players which can pick up IP streams and present them in full screen and all at different qualities. But one of the things we put all around each linear service then is a lot of program information and lots of different metadata. We have program information then, or metadata information, around the events that are in the service, the programs that we all get to see. And we have the same sort of technologies here that we're used to using in other broadcast events. We derive the DVB-I metadata, program metadata system from the TV Anytime system scheme, and that allows us to adapt programs and schedule them as we need to. We also allow the possibility to signal banners and logos for programs and service lists and lots of different aspects that we have in the system. Logos I think we're all pretty familiar with, but one of the things we can do with banners then is signal a visual image which can be shown at the end of a service. We're not used to necessarily having services ending, but one of the things DVB-I allows us to do is offer services which may only run for parts of a day. And so at that point, at the end of the scheduled period, of time the banner can be presented instead of having a video playing of something that's outside. We also signal content protection, and we also signal video and audio characteristics in the metadata. This allows the device that receives the service list to tune the service offerings to the end user based on the capabilities, the playback capabilities. Not all devices are the same. We know that. Not all devices offer the same content protection schemes. So this will allow the device to choose those services which it thinks can be presented and hide away some of the other ones that could not be presented. This is a decision based on the application makes, not the metadata. The metadata is provided for all characteristics, and the device chooses what to present to its consumer. Then within DVBI, we've spent a lot of time focusing on the ecosystem. What does it mean? What do you do with this technology? For many, many years, DVB created specifications which were standardized through ETSI, and we still do that. These specifications are being published through ETSI, and that was the end of it. We sort of left it there and let people pick up those specifications. We let markets pick them up and implemented them. Vendors created their own test specifications, or markets may have done it themselves. But here in DVBI, we're saying we found the realization that people need a little bit more help than that. So there's a few aspects that we've worked on here. One is the reference client. You can see in the top right-hand side of the screen here an example of that running in a browser window. This is a JavaScript HTTP application that we can use to present a service list and exploit most of the features and characteristics of DVBI itself. I think you'll see some examples of services on the side there. Some of them are low latency, some of them are regular streams, but they all can be played through a player that's integrated into this reference application. In this instance, we're using the -JS player to do the broadband delivery. On a hybrid television set, we can also receive through this reference application client broadcast services, and we use the HEBTV APIs in order to present those. The reference client is something that's really helped a lot of people get started very quickly. So far, we've seen several trials in different markets of the DVBI technology, and they've all been based on the reference client itself or variants of it. We make all of that code, all the backends, and the sample metadata are available publicly through GitHub. Another area we've been working on then is reference streams, and these are really, really important when it comes to building players which are compliant and will present the broadband media, at least in a manner which has been expected. So a lot of work has happened since the publication of the DVB A168 specification to create some video video streams which can be played through the -JS players and through other players on different devices. We've also spent a lot of time then building a DVB validator, and this has been done in conjunction with HEBTV, who use quite a lot of our specifications in their services. Now, this validator will check the manifests against the different specification versions, and it will also check the media segments as well. So then what else is DVB doing in this ecosystem? We've got lots of other technologies to make all this possible. We know that unicast streaming of broadband content is network intensive, so DVBI spent a lot of time creating its multicast AVR specification, which is now published as a blue book, A176, but it's also been published recently by ETSI, and you can find it on the ETSI standards website. This is really enabling very efficient delivery of broadband services across the network, using multicast between nodes, server nodes and client nodes, in order to leverage multicast on those managed segments where it can. To the device, the end device still uses unicast towards a gateway function and retrieves it as would be a normal DVB streaming session. In addition, within DVBI ecosystem, we're working on three more areas. One is targeted advertising, and we've been working for a long time on deploying targeted advertising in broadcast services, and now we're extending that to work with broadband services. A lot of that work will likely be based on aspects that have been developed by the Dash Industry Forum and other industry activities. So we don't see too much new happening there, but it will be quite useful in terms of integrating with the rest of the system. We're also working on a technology called DVB home broadcast, and that's to receive broadcast delivered services and then deliver them across the home on an IP network to a terminal device. It'll function in a similar way to a gateway, but it will create a DVB manifest and media segments, and also be able to provide DVB-I service lists to devices in the home, even though they're being served by a traditional broadcast network. We're also working on a very new piece of work called NIP, which is Native Internet Protocol. And this would be a way of delivering IP services directly over broadcast networks. It seems to be the way that everything is going. We're using IP to deliver everything, so we realize that we can leverage the efficiencies of a broadcast and the flexibility of IP into a convenient offering. We also recently started a work item on leveraging 5G delivery technologies for broadcast services, and we've seen a lot of industry activity around 5G. We won't be doing a lot of work with the delivery itself, but we'll be making sure that client devices and DVB-I service lists can integrate 5G delivery. So some additional reading. We've got the A177 specification published. That's the Service Discovery and Content Metadata specification on the DVB website and on the ETSI website. And you can also then take a look at the DVB-I reference client, which is available on GitHub. Thank you, everybody. Questions?